morning, everyone. I'll be speaking slightly quiet. It's early Sunday morning, and it's a beautiful day. The freeze has come in, and times are changing, and so we have to change with them. And so this is going to be an introduction to a new change in the way many of you probably should be drafting pretty quickly here. Notice that my computer's working pretty hard here. I don't know why my Civil 3D install is not so wonderful at home, but I'm going to first introduce you to the fact that I'm running Auto Civil 3D 2010. Most of you will be getting 2011, but I've made it look like AutoCAD, and I do that by going to the Workspace tab and changing it to an AutoCAD workspace. Now that workspace very likely might be something that you have out in your K drive. But if you notice here, I can make it look like Civil 3D by going to the workspace. I can make it look through. It's going to be very important to go eventually to tool-based and task-based geospatial. That is the AutoCAD map for many of you. I can go to 2D modeling, and I can go to 2D drafting and 3D modeling. All I'm going to do this morning is introduce you to It's 3D modeling. It's kind of interesting, and I'm going to go to 2D drafting and annotation. I'm going to introduce you to the concept of parametric drafting in a very basic way by introducing to the basic parameters of a couple of two-dimensional figures like a square, a circle, and a rectangle, and then show you how that program works in terms of using parameters to change things. I'm going to do this if I can. Turn off some of my other things going on here. So I've started with a drawing, and remember, we cannot forget that we never want to lose all our toolbars. So I'm going to say minus toolbar, and then say draw, show, and that brings up one toolbar. Right click in any toolbar, you bring up another set of toolbars. Layers, many of you are starting to use layers 2, almost as important or even more, except when it opens it goes to the other screen. There it is, it's up on top there. So I've got layers and layers 2. You can layers 2 there. You can right click on that one. I'm going to go ahead and pull it down here. Remember, when you grab on a toolbar, it will only give you the list of the toolbars in the same kind of sphere. So these are the AutoCAD toolbars. And I'm going to now introduce you to the concept of parameters. If you notice here, my scale is set to architectural, so I'm going to go ahead and change my units. I would actually, better yet, let's go File, New, and actually go to a drawing that has the units in it. You notice in this case it's jumping out to the DOT. However, we all have something hopefully called a K drive on our computers, and we have something called Standards AutoCAD, which I do not see here actually. I'm going to look again one more time. Somehow I lost my K drive thing. And go back to my computer. See if I have the K drive there. I do not. So knowing where your K drive is going to be important, and making sure that it is stacked with your stuff in plan sheet. That's not it. And I see somehow I must have copied the wrong K drive down. So once again, I'll go ahead and pull that from home, and I'm just going to then, because of that, I'm just going to go ahead and change the units with the units command. And I see that the units are set right, and what I was looking actually at was the annotative scale stuff. Alright, so that's way too much time for drawing a box. I'm going to show you now the basics of using parametric, and it's a whole turn things on your ear. This is an important shift to make for not only Civil 3D, at least in your head, but Inventor, SolidWorks, and eventually anything that's going to be parametric modeled. They say the key to doing parametric modeling is to sketch in the shape of the sketch, and that would generally be put lines where there are lines, arcs where there are arcs, and have the right number of vertices in the drawing, and then back in your description of your parameters. So what I'm going to do is going to just to draw a box here. I'm going to kind of go kind of up, kind of over, and then I'm going to go ahead and go to the endpoint there. You notice there, even if I do turn on the dynamic, right, you have just no snap showing, or nothing that shows that these lines are actually endpoint to endpoint. So the way this works in this program or in Parametric is you drew the shape, then the constraints, and then the dimensions. Now the constraints typically are you're gonna want to start and lock down one line, at least in terms of direction, then get your angles and your distances. But before you do that, you need to let the program know that endpoints are supposed to be attached to endpoints. I brought up the parametric again. I'm showing you this time with a ribbon and not necessarily right click in any toolbar. The parametric toolbar, which came up over here. I'll show you both. It's probably worthwhile, but excuse me, you'll see that your constraints are there. All right, so the most important one to start with is the coincident, and what you need to do is get near the ends of two lines, click them, and you see a little blue indicator come up. Doing the same thing there. Now I'm going to point out that you can use auto constrain, and we'll do that in the next exhibit. So you've got something there that is constrained. The next thing you're going to do is tie down something like a point or a curve to a fixed location. Interesting, a point or a curve to a fixed location. So we're going to go ahead and lock down that bottom, that left one right there. So that's locked down. That looks like it locked down the whole line. And now I'm going to take this constraint and make that vertical. See what it does. It immediately cleans that up. And now I'm going to go, there'll be two different ways to do this. You can make something perpendicular to something else, or you can do it by angular. And I'm going to do this one by angular. I go to the angular dimension. I click here and here. Bring my angular dimension inside, hit a return, and it just is going to take what I gave it. Again, angular here and here, inside there. It's going to take what I gave it. Angular here and here. Return is going to take what I get it. And I demonstrate that when you have given these coincident constraints, you have let it know that it is a closed polygonal figure, and it knows that the sum of the interior angles in that figure is the number of the vertices minus 2 times 180. So when you all of a sudden constrain those three and try to constrain this fourth, it takes you most of the way through, but then it gives you this error. So you've got three things constrained, and then the last thing you can do is you can constrain a linear. And I would generally tell you you're better off going with a lined object point and line, two lines. I'm just going to grab that, hit an escape here. I'm going to try again aligned. I'm going to go from that to that and pull it out here, and you see it has a distance. And now we have essentially the things that will define this rectangular figure. Now I apologize for everything being in the same color. What I'm going to do right now is I'm now going to go back to each of these, and I could change them here, but better yet would be noting angle 1, angle 2, angle 3, and then D1, and going up here in the parameters manager. And this again takes you back to why in fact you are often doing things like at something, angle something, or at something, comma something, to get used to this kind of basics of math and parameters. That's a bit of a stretch, but I'm looking for ways to get you all to at least tie yourselves into the mathematics of what's going on behind the drafting. What I can do now is go ahead and change each of these things. 90. I'm double clicking inside. 90. 90. And the distance I'll change to 2. All kinds of things to do there. I'm going to hit a tab here, hit X, and you'll notice that the drawing has been updated. I can now go here, double click inside there and change that. And you see it changed that sense. Now I'll do one more constraint here. There is the equals. So in this case, if I wanted to make this a rectangle, I would just tell it that this one equals that one. And then I could tell it this one equals that one. And I'll try it again, hitting escape, equal sign. I think in this case it will say it's going to constrain, I bet. So you see already I have my 3 and 3 because everything works out geometrically. I then have all the information that describes this. You'll see eventually this parameters manager is going to be important for animating and interrelating different drawings or different shapes in some sort of design. So whether that is the width of the road for Civil 3D or the cross-sectional diameter of a bolt in some sort of mechanical design, these parameters are going to be really the way that we go about doing things. So I will go quickly through to fill out the 15 minutes. Coincident, these are the constraints. Coincident, collinear, concentric, locked or fixed, which we did in the past, parallel, hate that, 2 lines to maintain the same angle in the 2D plane. You can always, it's amazing how much you can see AutoCAD hanging onto its 2D past. So that one there is the same angle from some defined datum, usually the x-axis, the standard position angle. Perpendicular. Horizontal. There's a key one of the current user coordinate system. Vertical. In other words, Y, not vertical in reality. Tangent. Smooth. Symmetric. And equal. You then have an ability here to show what the constraints, show all, hide all, so we can hide all, show all. We have different radial. I really don't like that term, but we'll live with it. Diameter. So radius, diameter, angular, convert. So that's actually nice. Converts dimensions to dimensional constraints. That's a nice way to go from having had done dimensions and then doing dimension constraints. And you can show or not. So that's, you can see that in the end you can kind of turn things on and off. So you're going to see that. I'm going to go ahead and just try this right now. I'm going to try to just put in a circle here, fill out this, put it here, and then I'm now going to try to do, and that means that that's going to remain tangent. No matter what I do with my grips now, if I go ahead and change my grips, it will keep that tangent. And it's not going to let me do some things because of that tangency there. All right, that's 15 minutes. Thanks for listening. That was an introduction to parametrics.